Does time go faster at the top of a building than at the bottom? Yes, compared to time on Earth's surface, time moves faster as you move away from Earth's surface. This effect is called gravitational time dilation. It was predicted by Einstein's general theory of relativity and confirmed many times by experiments. Gravitational time dilation occurs because massive objects create a strong gravitational field. The gravitational field is actually a curvature of space and time. The stronger the gravity, the more spacetime curves and the slower time. However, it should be noted here that an observer in strong gravity will pass his time normally. It is only relatively so that a person in a place with weak gravity slows down his time. So someone with strong gravity sees his time running normally and the clock with weak gravity running fast, while the person with weak gravity sees his time running normally and the other clock running slow. Nothing wrong with watches. Time itself slows down or speeds up because of the relativistic system in which mass distorts space and time. Gravitational time dilation occurs when there is a change in the gravitational force. The difference is very small. Earth's mass is huge, so gravity is huge, expanding space and time enough to measure it. As a person moves farther from the Earth's surface, even a few meters, that person's gravitational pull weakens. As humans, we don't notice it much, but even going from the first floor of a building to the second floor of a building takes you away from Earth and therefore slightly weakens the force of gravity you feel. The difference between the force of gravity felt 3 meters above the Earth's surface and the gravity felt 4 meters above the surface is too small to be sensed by our human senses, but large enough for sensitive machines to pick up. Because the force of gravity weakens with each step you take up a flight of stairs, your forward speed also increases with each step. People working on the lower floors of a skyscraper are literally walking into the future compared to people working on the upper floors. But the effect is very small. So small, in fact, that you would never notice the time difference in everyday life. People who live and work farther from the Earth's surface are only a fraction of a nanosecond per year compared to people closer to the surface. Although small, the time rate difference between different altitudes is real and has been measured experimentally using very accurate atomic clocks. The U.S. National Institute of Standards and Technology, NIST, measured such small time rate changes and published its findings. NIST was able to measure the small time rate difference between a point on Earth and a point half a meter high by raising their experimental table half a meter. Their findings fit well with the time dilation predicted by Einstein's theory of relativity. The time dilation caused by Earth's gravity is significant enough that GPS satellites orbiting above the Earth must adjust their internal clocks to account for their accelerated time so that GPS receivers must accurately determine ground positions. This is a letter from Dr. Christopher S. Baird. Subscribe us on YouTube, 1 Minute Knowledge.